This program is about the basic elements of ram-type blowout preventers. It covers the general operation, maintenance, and the use of ram-type preventers. More detailed material is available from the manufacturer. We are indebted to the various manufacturers for the material in this presentation. The ram-type blowout preventer was first developed in 1900. This is a Cameron preventer from the early 1920s. Notice that it has the basic elements of today's preventers. It was used as a one-ram BOP stack. Schaefer was marketing this model by the early 1930s. The chain on the right side is part of one of the early chain gear closing systems. The modern ram preventer is the result of 80 years of development, and it is strong, reliable, and simple to operate and maintain. Pipe rams will seal off a pipe to match the pipe bore in the ram. One of the newer ideas in pipe rams is the Cameron variable ram, which will fit several sizes of pipe without replacing the ram assembly. In this cutaway side view of a Schaefer ram, notice the small yellow arrows in the black. The black is the ram packer rubber, and the yellow arrows show the direction of the flow of the rubber to seal. The packer seals against the pipe and against the top of the body ram bore. In this top view of a Cameron ram, the black is the ram packer rubber, and the red shows the flow of the rubber around the pipe. The black rubber on the top of the ram flows upward to the preventer body to seal off the wellbore pressure from below the ram. Blind rams will seal an open hole. They are often used to close the hole when the drill pipe is out of the hole during a trip or repairs. Blind shear rams will cut pipe and close the open hole. This shows Cameron shear ram blocks. In this cutaway of Schaefer rams, the shear rams are closing and have dented the pipe. Here the rams have sheared the pipe and closed over the hole. Here's what the sheared pipe looks like. Pipe rams can be used to hang off the drill pipe. This is done on floating vessels for temporary abandonment of the well, such as in a storm. The illustration shows the pipe sheared by the shear rams at the top and hung off on the bottom rams. Take a moment to look at this illustration and identify the various parts of the Schaefer triple preventer. Preventers are built as single units, doubles, or triples to save height in the BOP stack. On multiple preventer sets, there are outlet ports below each ram, used for the kill and choke lines in place of the spool used for this purpose between single preventers. A number of years ago, most rams were operated by screw jacks that closed the rams manually. This is still used on some small rigs. Modern preventers use a hydraulic piston to operate the pipe ram. The ram is operated by hydraulic oil or soluble oil in water, normally at 1500 psi pressure. The hydraulic fluid pushes the piston forward. The piston rod pushes the pipe ram into the well bore and it closes around the pipe. The ram stays closed because normally closing pressure is kept on the hydraulic piston. As shown by the arrows, well pressure also helps keep the ram closed. And finally, the ram can be locked and closed mechanically. All rams in common use on surface stacks can be locked by the mechanical lock and closing screws shown on either end of this Cameron ram. This is a hydril ram preventer, which is very similar to the other brands of ram preventers. Notice the mechanical locking and closing screws. Cameron rams can be locked hydraulically by a wedge lock. that forces a wedge piston behind the ram extension piece. The wedge lock operates independently of the ram, and so it must be locked and unlocked from a separate valve on the control unit. The Schaefer ram has an automatic pause lock that causes a dog to fit over a lip that automatically locks the ram closed when it is closed. It automatically opens when the opening hydraulic pressure is put on the ram piston. Here is another view of the Schaefer pause lock. It shows the 3 steps in the automatic sequence of closing, shutting, and locked. To test the hydraulic system of the ram, close the ram with 1500 psi pressure around the proper pipe size. Isolate the accumulators by turning off the accumulator isolation valve. Watch the pressure. It should remain at 1500 psi for 15 minutes or so. Visually inspect the system for leaks. If the closing pressure holds and no leaks develop, the hydraulic system is in good operating condition. To pressure test the preventer for sealing the well, first set a test plug to protect the casing and open hole. Then close the rams to be tested on the pipe and pressure up to the rated pressure. Turn off the test pump discharge line so as to isolate the pressure in the preventers between the plug and the ram. Wait for 5 minutes or longer, and if there is no visible leakage and the pressure does not go down, continue on the test with the next preventer. Blind shear rams have very small packer elements. When the shear ram is pressure tested, the packer element is extruded to make a seal. Since the seal is small, do not pressure test shear rams more often than necessary because after several tests they will not seal. They may be function tested without harming the seal. The newer shear rams have larger seals and may be pressure tested more frequently. In all pressure tests, use visual inspection and a pressure gauge. Report anything that does not look right. The pipe ram should be function tested once each trip and no less than once each day. The preventer should be tested when installed, before drilling out a casing, after being repaired, and no less than once a week from each control station. Pipe rams should be function tested on drill pipe. Closing pipe rams on open hole or on the wrong size pipe may damage them. Closing pipe rams on open hole will extrude the packer rubber and may damage the face of the packer. Closing pipe rams on the wrong size pipe or on tool joints may damage the pipe or the ram face. Before opening pipe rams for inspection, be sure the hole is closed in by a lower set of rams or a plug. To open Cameron rams, back off the bonnet bolts until they are clear and apply closing pressure to the rams. The back end of the preventer, bonnet assembly, will come open carrying with it the pipe ram. To open Schaefer rams, be sure that the rams are open. Back off the cap screws until they are clear. Then open the door. If the rams are closed, the ram shafts can be bent by opening the door. In the LWS or LWP models of the Schaefer ram, closing pressure will have to be applied after the door is open to get the ram block out of the recessed door. Now install the lifting eye and lift the ram block off the shaft. Do not bang the ram block against the preventer body. You may damage a sealing surface. In some Schaefer rams, the block slides horizontally off the shaft. However, in the 15,000 psi Schaefer rams, the ram block lifts off. Put the ram block on a clean working surface. With the Cameron ram, the ram block is disassembled by first prying the top seal loose. Then pry the ram packer out of the ram face. Pry from one side, then the other. On the Schaefer ram, remove the 2 ram retracting screws that hold the ram holder to the ram block and remove the holder. Remove the 2 rubber retaining screws and pry the rubber from the back of the ram block, both from the top and bottom. Insert a punch through the holes of the rubber retaining screws and drive the front face of the rubber off the block. The next step on either ram block is to clean the block, being careful to get the grooves clean. Do not scrape or scratch, then lightly oil the ram block. To assemble the Cameron ram block, push the front packer into the face of the ram block. A soft hammer can be used if necessary. Press in the top seal, making sure that the pins in the top seal engage through the pins in the front of the packer. To assemble the Schaefer ram block, put the new rubber on the block and line up the rubber retainer screw holes. Then tap the rubber into place. Put in the retaining screws and pull up the face of the rubber into position. Pry the rubber at the back of the block to seat it. Put the ram holder back on and replace the retracting screws. The retracting screws fit on the large opening facing you. On either type of ram, before replacing the ram block, wash out the ram cavity and inspect it for damage. This is very important. Inspect the sealing surfaces in the ram cavity for nicks or damage. The cavity should be micrometer calipered for wear at least before every hole is started. On the Cameron ram, inspect the bonnet seal and replace it if necessary. Be sure that the seal groove is cleaned and lightly oiled if a new seal is to be installed. The mating surface should also be clean. Item 22 is the bonnet seal in the seal groove. Item 34 is retaining O-rings for the bonnet bolts. Item 12 is the bonnet bolts. On the Schaefer ram, inspect the door seal and replace it if necessary. Be sure that the seal groove is cleaned and lightly oiled before putting on the new seal. Do not use grease. On the Cameron ram, opening pressure will pull up the bonnet. Be sure that the bonnet seal pulls up evenly. Tighten the bolts from the opposite sides. When all the bolts are made up to the proper torque, the bonnet and the body faces should be metal to metal. See the manual for torque requirements on the bonnet bolts. On the Schaefer ram, swing the door closed and make up the cap screws. If any of the cap screws are sticking, pull them out and clean them. If the ram shaft leaks when the well is under pressure, there is a secondary shaft seal on the top of the bonnet case. It is activated by removing the pipe plug and turning the activator screw to force the plastic sealer around the ram shaft. Here is the secondary ram shaft packing. On top is the pipe plug, then the injection screw, the packing, and the plastic check valve. Remember, in dealing with rams, blind rams close only on the open hole. Pipe rams close only on the right size pipe. If pipe rams must be closed on an open hole, reduce the closing pressure to about 500 psi. Use 1500 psi to operate the rams unless there are other orders. Manual ram locks must be opened before opening the rams. Cameron wedge locks must be opened before opening the rams. Schaefer pause locks open automatically. Pipe rams are well energized so that the well pressure helps keep them closed. Normally you would not open rams with pressure beneath them. This could damage the face seal. Pipe rams are a basic part of the blowout preventer. If you know how to use them and they are given some basic care and maintenance, they are reliable and almost failure-proof. This is the end of this presentation on ram preventers by Bill Ream. This show could not have been made possible without the cooperation of manufacturers, notably Cameron, N.L. Schaefer, and Hydril. A debt of gratitude is owed to them. Please rewind the tape and reset the slide projector.